Hey guys, go ahead and copy down the FLT here. This one is on absolute versus conditional convergence, okay? Press play whenever you're ready. So, given a power series, you're going to be able to determine if the series will converge absolutely, conditionally, or if it just diverges, okay? And how is this any different from what we've been doing before with all of the other tests, right? And, in a nutshell, it really isn't any different, okay? It's just a very strategic way of finding out if something converges or not, okay? And I'll show you what I mean by strategic. So here we go. Go ahead and write this down here. Not necessarily our first example, but just an example that I want to show you guys first. So determine if the series 1 minus a half minus a quarter plus an eighth minus a 16th minus a 32nd plus a 64th, and so on, converges. So if you take a look here, okay, it doesn't really alternate in sign. In fact, it's like positive, then negative, negative, then positive, then negative, negative, then positive, then negative, right? So it doesn't really alternate like we're used to with a plus or minus, plus or minus, plus or minus. So how do you tell if this series, because this is just written in expansion form, how can you tell if this series will converge or not? Okay, so here's what you do. We know that 1 minus a half minus a quarter plus the eighth. I'm just copying down what we have here. Minus a 16th minus a 32nd plus a 64th. We know that that series, okay, I'm just going to draw a line in between. Actually, you know what? Let me not. I know that that is definitely less than the same thing. So I'll just copy paste this. I know it's definitely less than everything positive. So just think about what I just said there, okay? Why is it that the original series is less than everything that's positive, right? And it kind of makes logical sense here. If you're subtracting values here, you're going to make things smaller. So if you add those same values, obviously you're going to make them larger, okay? So why did we do that, right? So what we did here was we turned every negative value into a positive value, okay? In the math realm, when you turn something negative into a positive, we call that the absolute value, all right? So here, I have a challenge for you guys. This is written in expansion form, okay? What is it in summation form? Pause there, press play when you're ready. What's the pattern here? How do I get every single term? Press play whenever you're ready or if you're stuck, okay? Okay, so here you notice that the numerator is always 1. And the denominator starts at 1, and then it turns into a 2, 4, 8, 16, 32, 64. That's pretty much 2 to the n power. But n has to start at 0. Okay, go all the way to infinity. Not super transparent. Don't worry if you didn't get that. But practice every chance you guys get, okay? When n starts at 0, 2 to the 0 is just 1. And 1 over 1 gets you the first one that we have. This right here, I want you guys to tell me if this series will converge or diverge, all right? Pause there, press play whenever you're ready. So here, this can be written as 1/2 to the n power. So I would definitely run the geometric series test, okay? And because r is 1/2, which is definitely less than 1, we know that this is going to converge by the geo series test. Okay. Actually, for the geometric series test, can we figure out what it converges to? Okay. What value does this converge to? Go ahead, pause and press play whenever you're ready, but figure out at what value does this series converge? Okay. So in the numerator should be your very first term. So your very first term is 1 over 1 minus whatever r is. In this case, it's the 1/2. Okay, and if you clean that up, you're going to get 2. So it converges to 2 here. So take a look, all right? This series on the right converged, meaning that it's finite, right? Meaning that it overlaps at a certain amount of space here. So is there a statement that we can make about the left series over here? Okay. So what you should be doing is you could use the direct comparison test. Since the larger series converged, right? Since the larger one converged, then the smaller one definitely has to converge as well. All right? So therefore, that one converges by direct comparison test as well. Okay, so here's what we're doing. Because you guys already learned the direct comparison test. So what are we really doing here? So the very first step we made was we took the absolute value of everything. Okay, meaning we are turning every term positive. Okay, so what we're really doing here is it's just another way of finding if a series will converge in a very different way. Okay, so what we're doing is we're going to see if this converges absolutely. All right. So when something is absolutely convergent or converges absolutely, I'll give you guys some time to write this. Okay, I want you guys to think converges absolute valuely. Okay, the cool thing in math is you get to make up words. So when you hear the word absolutely, think about absolute value. Okay? And then we'll go over conditionally convergent and diverge later, okay? But if something converges absolutely or is absolutely convergent, that means that it converges absolute valuely. Okay? Here's what I mean by that. Make sure you guys write that down, so pause if you need to, but I'm going to move on. Here's example 1. I'll write down the directions once, okay? Determine if the series converges absolutely, converges conditionally, or diverges, okay? I don't have room, so that's why I'm smushing it together, but go ahead and write that down. That's generally how you're going to see the instructions. There is no variation of that, okay? Determine if the series will converge absolutely, conditionally, or if it diverges. So here's part A. So when they ask you this, you're still running your tests, but you're going to go in a particular order, okay? So I'm going to make a note here. You're going to look in this particular order, 1, 2, and 3. You always go in this order, okay? If they ask you if a series will converge absolutely, conditionally, or diverges, you're always going to check for the absolute first. So what you do here is you take the same series. I'll write it out again, and you guys should too. Okay? And what you do here is converges absolutely means that you're taking the absolute value. So we're going to take the absolute value. If you want to check to see if it converges absolutely, right? Okay, that's really it. Nothing else changes. So remember that when you're taking the absolute value of any alternating term, so for instance, in this case, we have this alternating term here, this negative term, that pretty much goes away. Because if you're taking the absolute value of it, it's going to turn positive. Just think about it. If you expanded your series, right, and your series alternates, what you're really doing at a very fast pace is you're just turning all of those negative terms into positive terms. Okay? So what you're doing there is now you have 1 over 3 to the n. This n starts at 1 and goes to infinity. Okay. So once you take the absolute value of it, you're going to run your test to see if this new series will converge or diverge. Okay? Go ahead and run your test here, and then make a conclusion whether it converges or diverges. But as always, justify your statement, okay? Press play whenever you're ready. Okay, here I would definitely run the geometric series test. Seeing as how r is 1/3, you might have to rewrite that. We can then say, therefore converges by geoseries test. Okay, now we ran the test for our new series. Our new series is the one that we took the absolute value of. So notice how it just converged. So right away, therefore, this series converges absolutely. Because we took the absolute value of our general term and we were still able to make it converge. Okay, meaning that the original series will have to converge as well. It's based on this here. Okay, by the comparison test, we're able to figure out that since the absolute value series converged, the smaller one is going to have to anyways. Okay, but you don't have to use the direct comparison test to reinvent the wheel every single time, okay? So if you take the absolute value, and then if the new series converges, then you could just say that it converges absolutely. We were able to justify it here. That's basically it. Okay? Now, if you took the absolute value of your series, and you find out that the new series does not converge, then it does not converge absolutely. And then we move on to our next step. Okay, but you will see it as we do a couple more. Here we go. Here's part B. Go ahead and write it down. Okay, remember, same directions. Determine if the series will converge absolutely, conditionally, or diverges. Okay, first step. We take the absolute value. Okay. So what happens when you take the absolute value of this general term here? Basically, you're going to end up with everything except the alternating part because that turns positive. So you're going to have 1 over n squared. Okay, make sure you understood that. This alternating piece will end up turning positive. Okay, we're checking to see if this converges absolutely because we took the absolute value, okay? Run your tests here and then make a conclusion. Press play whenever you're ready. Okay, so here you would have definitely ran the P-series test. Okay, so remember with the P-series, and it takes a lot of practice, okay? Your P came out to 2 here, okay? So since P is greater than 1, we know it's going to converge. You're such a child, Mr. Lee. All right, so since P equals 2, therefore converges by P-series test. Okay, so what's my ultimate conclusion here? If the new series converged, therefore this series converges absolutely because we took the absolute value, okay? That's a very easy way to remember it, all right? Cool, let's keep going. Part C. Here we have the summation of cosine n over n squared as n starts at 1 and ends in infinity. Okay. First step. Actually, you know what? Try this on your own. Press play whenever you're ready, okay? Here, we're going to take the absolute value. Okay. Now, remember that here, cosine of n, remember, if n starts at 1, you got the cosine of 1 over 1 squared, then the cosine of 2 over 2 squared, then the cosine of 3 over 3 squared, and so on. Okay? If you take a look here, a lot of people see trig functions and they think it alternates right away. It doesn't. It has to have that pi there, all right? So here, notice how we're not really sure what's happening, okay? So I'm going to keep the cosine inside the absolute value. And since n is being squared, we already know that's going to be positive, okay? What you guys got to do here now is, this does not look like any basic test that we can run, okay? So we have to compare it to something, okay? Think about what you would compare it to, and then write it over here. Okay, this one tends to be a little bit challenging because you don't get to see cosine too often, but think of it this way, okay? Cosine is a waving function starting at 1, so it looks a little bit like this. Okay, but we took the absolute value of it, so pretty much cosine always comes out positive, so I'll draw it in green here. Basically what happens is you're going to get something like this, because everything below turns positive. So it kind of looks like a bouncing ball, but it never decreases in size. Okay, so look at how high and how low that graph goes. Okay, it goes up to about a value of 1, and it goes down to a low value of 0. So the range here is from 0 to 1. So I can compare it to 1 over n squared. Cosine has to be at most 1, so it has to be less than. Actually, the more technical way of writing this is less than or equal to, but I'll save that for later. Okay, actually, no, I'll put it in there now. Now, the or equal to really doesn't matter, you guys. Don't stress too much about that part, okay? So here's what we got to do. We compared it to something. I'll draw some arrows here. What do you guys know about that series? We had that exact same series in the previous problem. We know that it converges by the p-series test. Okay, so if the larger one converges, then we know that this one definitely has to converge as well by direct comparison test. Okay, so we found out that the absolute valued series converges. So what does that say about the original series, right? You kind of have to keep track of everything. Therefore, this series converges absolutely. Okay? Make sure the logic is there, you guys. Don't just go through the motions. Try to really understand what's happening and why it's happening there, okay? All right. Let's do a couple more. Part D. All right, so we'll move a little bit faster. We're going to take the absolute value. So we take the absolute value of our general term here to see if it converges absolutely. Okay, the absolute value will knock out that alternating part, it'll turn it positive. So you're going to have pretty much 1 over n. Okay? Think about what happens there. Press play when you're ready. Hopefully this doesn't take too long. This is a very common one, you guys. Again, it pops up a lot. You guys should know that this diverges. By the P-series test, or I hope you guys said that it diverges since it's harmonic. Okay? Okay, so we took the absolute value of the original function and we found out that it diverges. So what does that mean? So that means, let me write this out. So remember, we have 3 choices. Converges absolutely, converges conditionally, or diverges. We go in order. So since the absolute valued function diverged, we can say that it's not converging absolutely. So we're going to cross that out. Okay, so the next step is to check to see if it converges conditionally. All that means is look at the original function. So conditionally just means the OG function. Okay, the original function there. So take a look. If I gave you exactly what we started with, okay, what tests would you guys run here? Okay, pause and press play whenever you're ready. So here, you could actually use, you could go in 2 different ways here, all right? You can definitely use the alternating series test, okay? And you could find out that it converges because the limit of 1 over n as n goes to infinity goes to 0. So we can say that it converges by the alternating series test. Or if you had a really good eye on it, you could have said that since this is a alternating harmonic, it converges. It's not by, it should be since. It's okay. Okay, so let me go through the steps with you guys again. We checked to see if the absolute valued series converges, and it didn't. So it's not converging absolutely. So then we checked the original series here, and by running a few tests, we found out that it converged. So what does that say overall? Therefore, this series converges conditionally. Okay? The third thing you guys have to think about is, well, if the original series, if the OG series does not even converge, then it's just going to diverge. And there's your third case, okay? But that's it. Let's try some more. Here we go. Try this one on your own now, all together. Go as far as you can. If you happen to get stuck, you can press play, okay? Okay, here we go. So we're going to check for absolute convergence. So we're going to take the absolute value. Okay, that'll get rid of that alternating piece at the top. So we're going to have 1 over the square root of n, or n to the 1/2, just to make things a little bit easier. Okay, here I would definitely run the P-series test. Okay, and since P is 1/2, which is definitely less than 1, we know that this right here will diverge. Okay. Okay, so what does that say? It's not going to be converging absolutely. So we're going to cross that out. So now we're going to check for conditional convergence, which is just the original series that we started with. Okay. Okay, here I notice there's an alternating piece, so I'm going to definitely run the alternating series test. I'm going to take the limit as n goes to infinity of everything except that alternating piece. That there will go out to 0 since the bottom gets larger faster. which tells me that here, this will converge by the alternating series test. So therefore, the giant therefore, this series converges only conditionally, but not absolutely. All right? Cool. So let me see. Let's do this one, okay? So this is part F. Okay, now what I do want to say about this is because of the phrasing, you're only looking for absolute convergence. Okay? Because they phrased it this way, you're only checking to see if it's absolutely convergent. So it does make your problem a little bit shorter in most cases, okay? Try this one out. And then press play whenever you're ready. Okay, if we want to see if this is absolutely convergent, we take the absolute value of our general term here. Okay, that'll get rid of -1 to the n. So we're just going to have n cubed over 3 to the n power, as n starts at 1 and ends at infinity. Okay, what do we do here? What would you guys do? Okay, so definitely not P series, not geometric series. The divergence test would fail. I want to say the ratio test. Okay, honestly, I don't remember how this problem was played out, but since I see a 3 to the n power, I'm thinking the ratio test. So let's run that one real quick. So we're going to take the limit as n goes to infinity of the absolute value of our n plus 1 term. Okay. Divided by the general term or multiplied by the reciprocal. Okay. So here, I notice that 3 to the n and 3 to the plus 1 will reduce out to 3 at the bottom. Okay. So here I basically have the limit as n goes to infinity of n plus 1 quantity cubed over 3n cubed. Okay. Now remember, the numerator can be expanded out, but you're only paying attention to the largest degree term, which is 3. So since they're both traveling at the same speed, if you will, you look at the coefficients. So this actually comes out to 1/3. Okay? And according to the ratio test, this 1/3 comes out definitely less than 1, so we know that this will converge by ratio test. But even the bigger picture, therefore, this series converges absolutely. Okay. Now, if it didn't converge, you're pretty much done there based on the phrasing of the question, okay? Because they're only asking for absolute convergence. Try this one out. The more exposure you guys get, the better off you're going to be, okay? Okay, press play whenever you're ready. All right, so here we're going to run and check to see if it's absolutely convergent first. So we have -1 to the n power, n factorial all over 2 to the n as n starts at 0, ends at infinity. That will get rid of your -1 to the n power. And you're left with n factorial over 2 to the n power. Okay? Now here, you could have done this in a few ways. I think most of you guys would run the ratio test, but I believe the ratio test would fail here. I could be wrong. But what I noticed, okay, and you guys should always have this in the back of your mind, is the divergence test, okay? It's not so transparent, but let me show you guys, okay? N factorial is pretty much 1 times 2 times 3 times 4 times 5 times 6, and it goes on forever. Okay? 2 to the n is 2 times 2 times 2 times 2 times 2 times 2. Okay, when you write it out like this, think about where it's going to get larger faster. And you kind of have to really think about this. Okay? So it's not so transparent whether an exponential is larger or if a factorial is larger. But actually, a factorial grows larger in the long run than 2 to the n does. So although it starts off at 2 instead of the 1, notice how the numbers get increasingly larger while the bottom just stays at a constant 2. Okay? So here, if you actually ran the divergence test, so very quickly running the divergence test, you find out that this will go to infinity, which is definitely not 0. Okay? Therefore, diverges by the nth term test or the divergence test. It doesn't matter. So what does this tell us here? It's not going to converge absolutely. So we check the original one. Okay, so here we go. We have the original series. I would, initially I would use the alternating series test here because there's that alternating piece. But I noticed that there's factorials and exponents. So I would probably lean towards the ratio test, but I could be wrong. So let's run the ratio test here. We're going to take the absolute value of -1 to the n plus 1, n plus 1 factorial over 2 to the n plus 1 times the reciprocal 2 to the n over -1 to the n factorial. So because of the nature of the absolute value, it'll get rid of the alternating parts. Okay? Because of the absolute value, it'll get rid of the alternating parts here. N plus 1 factorial and n factorial will reduce out to n plus 1 in the numerator. 2 to the n and 2 to the n plus 1 will reduce out to 2 in the denominator here. Okay? So we have the limit as n goes to infinity of n plus 1 over 2, and that comes out to infinity. Okay, let me double check the ratio test here. I want to say that it diverges. Yeah, it's definitely larger than 1. Therefore, diverges. I'll say because it's greater than 1, it diverges by the ratio test. Okay, so look, I'll highlight it in pink. We ran the absolute value test, and we found out that it didn't work. Then we ran the conditional test, and we found out that that doesn't work either. So what does that resort to? Giant therefore. Therefore, this series diverges. Okay, it doesn't converge absolutely or conditionally. All right. Let's do one more. Okay, what letter are we on? H. This last one here. And then press play when you're all done. All right. Okay, here we're running the absolutely convergent process. So we take the absolute value. Okay, that'll get rid of the -1 to the n power. So we have 1 over 5n plus 1. Okay. So here it's not too transparent, but I would definitely compare it. So down to its bare bones, I would definitely compare this to 1 over n. If you did 1 over 5n, that's going to work too. Okay. Now here, notice how you have to make a comparison. Can you quickly tell if it's less than or greater than, right? Okay, so notice how with the left series, the denominator is getting larger, meaning the overall value is getting smaller. Okay, so this has to be a less than. Okay, now we know that this here will diverge because it's harmonic. Okay, now if the larger series diverges, does that guarantee that the smaller one will? Okay, so notice how this doesn't work. Okay, so here, I mean, we can't say that it diverges. We're just at an inconclusive right now. So let's try another avenue. Let's try the limit comparison test. So the limit as n goes to infinity of one on top of the other, okay, this is going to come out to 1/5. So let's take a look at our limit comparison test. Okay, so the limit comparison test says that as long as it comes out positive and finite, they both will behave the same. Okay, so here we go. We see that it's positive and finite. Therefore, both series will behave the same. Okay, so back to that previous point. We know that this is harmonic, so this will diverge since it's harmonic. Okay, so then we know that this has to diverge as well, right? Diverge by limit comparison test, since they have to behave the same. So what test did we just run here? We were checking to see if it was absolutely convergent, okay? And it diverged. So we know that it's not absolutely convergent. So we run on to our next test. We check to see if it's conditionally convergent. So we look at our original series. Okay. Here I would easily use the alternating series test because of the -1. So we take the limit as n goes to infinity of everything except the alternating part. This here easily goes to 0. And if it goes to 0, you know that it's going to converge. By the alternating series test. But again, what's the ultimate answer here, you guys? Okay. Therefore, this series converges conditionally. All right. This does pop up on your FRQs. Sometimes it'll pop up on your multiple choice questions as well. But it's easy nonetheless. It takes a little bit of time, but the more and more you guys practice your tests, the faster and faster it's going to be, okay? That's it here. So remember, just to wrap it up, to check to see if something converges absolutely, it converges absolute valuely, okay? And if it converges, you're good. If it doesn't, you check to see if the original series converges conditionally. And if that doesn't work, then it just diverges. Go in that exact order. And that's pretty much it. All right. It's another chance for you guys to practice your tests for convergence. All right.